your quizzes, so I'm not really sure how you did, so I can't really say. Why isn't that? Okay, good. So let's take a look and let's write the solutions for this quiz. We are told that a fruit company recently released a new apple sauce. By the end of the first year, the profits were 30,000, and at the end of the fourth year, there were 66,000. Obviously, these are two ordered pairs. You have to be very careful how you set them up. Time is always independent, and whatever profit in this case is the dependent variable. So this is the correct setting. And I'm asked to find or write a linear equation that fits the information. I have to find the slope first. 66,000 minus 30,000 divided by 4 minus 1. And the numerator is 36,000. The denominator is 3, so 12,000. If you left it at 12,000, I cannot give full credit. So you have to write the measurement unit. The measurement unit is dollars per year. Without a measurement unit, I will not be able to give full credit. So please keep that in mind on the test. Okay. Then I will be using the equation y minus y1 equals the slope times x minus x1, in which I will plug in 12,000 and I will plug in 1 and 30,000. So I have y minus 30,000 equals 12,000 multiplied by x minus 1. So when I distribute and combine like terms and so on and so forth, I just needed more paper. We get y equals 12,000x minus 12,000 plus 30,000, which is positive 18,000. So this was the answer, this portion, and this is the answer to the first part. Use this equation to predict what happens in the 7th year, which means x equals 7 years. So then y equals 12,000 multiplied by 7 plus 18,000. Whatever that is. And then predict the profit. When the profit will reach 126,000, the variable y is given now. 126,000 equals 12,000 x plus 18,000. Just plugging in numbers and give me a number as an answer, I cannot give credit for that. So if there is no work and you just come up with 102,000 or 9 years or 8 years, I can't give any credit for that. You have to show me your work. It says show all your work for full credit. So please keep that in mind on the test. Plugging in the graphing calculator, everyone can do it, but you are taking a college algebra course and you have to show your work. Because I don't, this is what I show you, so I can't say, I don't come to you and say, hey, the answer is x equals 10 years. No, I show you step by step how this is done. So I'll have to move 18,000 to the other side. 126 minus 18 is 108,000, and then 12,000 x, and then x 108,000 divided by 12,000. And yes, you can calculate that with a calculator. Any questions on this part? So this is the correct setting, and you have to show all your work. Okay, so please make sure that you remember that. Okay, now the other quiz, how many do I have here? Oh yeah, there's 4 people who are missing. Yes, I do have 4. Okay, so the other one, solve the system by the method of your choice. Before you even decide the method, it's highly recommended to eliminate fractions. In order to eliminate fractions, we will multiply the first equation both sides by 3, and of course the second equation both sides by 8, because those are the respective least common denominators. Yes. So from here, I will have 3x minus y equals negative 3. And from here, I will have negative 4x plus y equals 2. Now, at this point, it's already set up. I don't have to do anything else, really. Just add the 2 equations. And when I add those two equations, y's go away, and I have negative x equals negative 1. Therefore, x equals 1. Now, it doesn't matter where you want to go back, but you just have to go back to any of the two equations. You plug it in. 3 minus y equals negative 3. Negative y equals negative 6 because you have to move 3. So then y equals 6. It appears that the solution is negative 1, 6. If you don't show me that you checked, I cannot give full credit. It's part of the problem. I'm kindly asking you to go back and check in the original problem. I don't trust this before I check. So I go back to negative 1, 6. I'm sorry, positive 1. It's positive 1. I just wrote it. Okay, so positive 1, 6 and 1, 6. Let's see what we get. 1 minus 6 divided by 3 is 2. 1 minus 2 is indeed negative 1. Yes, I have to check the other one. So negative 1/2. 6 over 8 is 3 over 4. And now I find the least common denominator. Multiply the top by 2. Negative 2 plus 3 is 1/4. And the right-hand side is 1/4. And I'm going to say yes. I checked in both. It works. It's the only solution. So the system is consistent. There is a unique solution. And the equations are independent, as we discussed last time. Any questions on this? Any questions? Okay. Now, one more time. Any questions for me? From anything you worked on? Anything? Well, okay. So the plan for today is to finish up sections 8.2 through 8.4. And if we have any time remaining, we will review for the test. So let's go back to, let's start with 8.2. In 8.2, we will look at non-linear functions. And we will only look at two nonlinear functions. One is an absolute value, and the other one is the square root. Functions. So the absolute value function is the simplest possible one, is the absolute value of x. We're interested in looking at the graph. We want to graph this function, and we want to remember the graph, hopefully forever, and find its domain and range. Every time I'm asked to graph a function, that's my first thought. I have to find its domain. And then I will graph the function and identify its range. So can anyone give us an idea about the domain of this function? What do you think? And if anyone can say, I know how to determine the domain and what I'm really asked to do, and so on and so forth. Does anyone want to say anything about that? So we have to find the domain of this function. For any function that we need to graph, the domain is the first step. Can anyone tell us how to find the domain of this function?
1 by 1.
What does 1 by 1 mean?
If the function is 0, then x has not 0. If the function is 1 in the parentheses 1.
If x is 1,
then your answer would be 1.
Good.
Sorry, yeah.
Good. And you can continue forever, right? So my question about the domain is, one more time, the domain refers to what values of x I can plug in this function. I don't have to do anything for this function. As you see, I have my hands in my pocket. I'm just looking. Okay, I'm looking at this and say, what can I plug in x? What can I replace x by? It's just a discussion. I don't have to do anything for this particular function. For other functions, I have to do something to determine the domain. But for this one, I have to just look. So what x values I can plug in here? Absolutely. I can plug in anything, and I will always be able to give you an answer back. Very, very good. So therefore, I'm going to create a chart of ordered pairs, I will pick some x values, and I will determine the corresponding y values. So let's say -2, -1, 0, 1, and 2. Please plug in -2 in the function and tell me what you get. Very good. Let's plug in -1 in the function and tell me what you get. Good. Please plug in 0 in the function and tell me what you get. Please plug in 1 in the function and tell me what you get. And plug in 2 in the function and tell me what you get. Very good. That's all we need. Can anyone dictate from left to right the first ordered pair that we need to plot? Very good. Excellent. Here it is. The next ordered pair that we need to plot. I'm here.
-1.
Very good. Next one. Very good. Next one. Very good. And the last one that I have. I can continue forever, but this is the graph. We should remember from now on that the absolute value function looks like a V. Once I have the graph, I will be able to identify its range. Can anyone give us the range of this function? Excellent. With a bracket. Very good. 0 to infinity. Perfect. Let's suppose I create another absolute value function. I'm going to call it g this time, and I'm going to say x plus 3 in absolute value. What do you think I did to this function to get this function? I changed x into x plus 3. What do you think that this change into x, from x into x plus 3, will do to this graph?
It moved your y intercept up 3.
Nope, we haven't changed y. We changed x. That's why I specifically asked you, what did I do to x, in other words? I changed x into x plus 3. It must be, careful,
Left.
to the left.
Opposite.
Yes, it is. So this graph will only be this. So the absolute value of x plus 3. We can do the same thing, meaning we can establish its domain, which is the same thing, -infinity to infinity, and find ordered pairs, and by picking x values and determining the corresponding y values like we just did. How do I know that this graph moves to the left? Let's plug in -3 in this function. What do I get? Right here. Correct? What if I want to create another function, let's say h of x, which is the absolute value of x minus 2? What will happen to the original function by replacing x by x minus 2?
Now it moves to the right.
Now it moves to the right, because at 2 minus 2 will be 0, and this is a point on the graph. So this is left 3, and this is right 2. Any questions? Okay. Now, Tom, if you would like, look at this. Let's say I have f of x is the absolute value of x minus 2. What will happen now, and what did I change? And the question is, did I change x or did I change y?
Y.
I changed y. Because see, from the original function, the simplest possible absolute value function, I did not change x, but from the original, which was y, now I have y minus 2. Where will this graph go?
Down.
Down 2, indeed. Down 2. What if I have another function, let's say t of x, which is the absolute value of x plus 4? Where will this graph go? Right, because I changed y. See? This was y, and now I have y plus 4. So this is up 4. Okay, so now we should remember how to graph the absolute value. It's a v function, and there are shifts, potentially shifts, if we change the base function into something else. Okay, now let's look at the second function, which is the square root. So I have f of x equals the square root of x. This is the simplest possible square root function. It has no transformations on it, no shifts, nothing. It's just the pure square root. Did I say exponential? I'm sorry. Square root. Okay, so now this is not a friendly function. The absolute value, I call it friendly because I know I can plug in here anything I want, and I will always be able to give you an output. If you say plug in 5, I'll give you an output. If you say plug in -3, I will give you an output. And I will be able to give you an output for everything. Not for this function, though. We're going to talk about these functions in chapter 10. It's a long chapter. We're going to address this in detail. But for now, we just want to see the graph. Well, whenever the index is an even number, because here you can say, what is the index? The index is the number in here, and you can say, but I don't see a number. By convention, the square root should have a 2, but by convention, we don't write it. And that's the smallest index possible. So I can have index 4, I can have index 3, I can have index 5, and so on and so forth. Every time the index is even, like for the square root, this quantity, everything that is under the square root, must be positive or 0. And you'll see in chapter 10 that if the index is odd, anything goes. No restrictions. Fine. Anything. I can take an odd root from anything you want, but I cannot take an even root from a negative number. The answer will not be real. So, coming back, we want to graph this function. How do I graph it? Well, I have to find its domain first. For the absolute value function, I only observed. I didn't do anything. I didn't write anything. I only asked myself, what can x be? And I said everything. In this case, I have to write something before I establish or I state the domain. And what I have to write is exactly what you see here. I'm asking myself, what is the quantity under the square root? And I see it's x. Well, then x must be greater than or equal to 0 according to this condition. So therefore, the domain of this function is not all real numbers, but is 0 to infinity. So now I'm going to create a chart that presents a 0 to infinity. That's the reason why I have to start with a domain. It's 0 to infinity and nothing else. I will pick some values of x and determine the corresponding y values. So please give me like 4 values of x that it's easy to take the square root from, and I have to start with 0. That's the starting point, mandatory. So how much is the square root of 0?
0.
Thank you. Please give me 3 other numbers that I can take the square root from easily.
4.
Very good.
16.
Okay, let's say 9 and 1. How much is the square root of 1? Good. How much is the square root of 4?
2.
How much is the square root of 9?
3.
That's all I need. Please keep in mind that the absolute value was a v function, and this is the square root, and it will not be a straight line. We know a line is a line, and it's a linear function. This is a square root. So the graph will look like this, as we know nothing here, right? The first ordered pair that I need to plot is
0, 0.
correct. Next one. And then the next one. And then the next one. Be careful how you graph it. It's not a straight line. So this is f of x equals the square root of x. Now, I want to ask you, for example, to find the domain and graph the function the square root of x plus 2. What will you write to find the domain? Again, for this function, or for functions that are not friendly, as I like to call them, well, I have to do some work. I cannot just, maybe I could, but I still have to write it. So what will you tell me to write, solve, in order to get the domain? So let's go back to the page and tell me what to write. So the function is the square root of x plus 2, and look at this and tell me what to write.
I want to say 0.
You cannot say 0.
No, you can't say 0, but you're adding 2.
I'm not adding anything yet. I have to state a restriction, solve the restriction, and then I'll find the domain. First, I have to write something. So what will I write?
What is x? What is x?
Not yet. I don't have x. So one more time, the restriction says this. If the index is even, whatever I have under the square root, whatever, in this case I had x, I have to state the restriction that x must be greater or equal to 0. Here I had x, but in general, whatever I have to state it greater than or equal to 0. So what will I have to write? Say it again.
Greater than or equal to.
I can't. I have to state the restriction and then solve. So what do I have to write first?
X is greater than or equal to 0.
I cannot solve that. I just need the restriction first. Don't solve anything. Just tell me the very first step, what to write. Don't solve any inequality. Don't solve anything. Just tell me what to write. And then we'll solve it, of course. But I want everyone to see what they have to write first. Everyone is giving me already something solved. I don't want to solve it yet. I want everyone to see it first.
I'm going to say x is greater than.
Don't solve it.
I'm not solving. Like, just trying to.
You are on the right track, no doubt about it. But just don't solve the inequality. Tell me the raw inequality first for everyone to see it. Okay, let's go back. Whatever greater than or equal to 0. What will you tell me to write? What is the whatever in this function?
So whatever is x plus 2.
Thank you. That's all I wanted you to say. That's the whatever. What we see under the square root is x plus 2. That quantity, in this case, is x plus 2. It could be x minus 5. It could be 2x plus 9. It could be x squared minus 15x. It could be whatever. It has to be stated because the index is even. It has to be greater than or equal to 0. Now I'm ready to solve it. What will you say? X greater than or equal to? To what?
2.
2, right?
No. If 2 is on one side, it's positive. It cannot be positive on the other side.
You can't go to -2 because
Why not? This is a horizontal shift of 2 units to the left.
You can go to -2 because.
Exactly. 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 I have to move this to the other side, right? So then the domain is indeed -2 to infinity. And that's exactly what we expected to happen. Because if you remember a minute ago with the absolute value, when we replaced x by x plus 3, what happened?
Shift it to the left.
Exactly. Now I replaced x by x plus 2. What will be this. How will the g of x look like? Same thing, but shifted to the, exactly. We can look at the domain. It has to be shifted to the left, right? So 1, 2, this will be the graph of the square root of x plus 2. I know that's the domain. When I replace x by x plus 2, the graph shifts to the left. What about this graph? Let's say h of x equals the square root of 2x minus 3. For this graph, I only want the domain. What do I have to write and solve? Don't graph it. I just want the domain. Tell me what to write.
2x minus 3 is greater than or equal to.
Excellent. That's all I want. Now I will move 3 and divide by 2. That's a different story. I know how to do this. We've reviewed inequalities. So then the domain of this function is 3/2 infinity. That's all I want as the raw inequality, as the first step for everyone to see. And then, yes, we'll have to solve it. See the difference between these two functions? For this one, I didn't have to do anything. I just looked and I said anything goes, domain, all real numbers. For this one, it's not that easy. This is not a friendly function. For this one, I have to work to find the domain. What do I have to do is state that this quantity is greater than or equal to 0, or state that this quantity is greater than or equal to 0 because the index is even. Good. For some reason, I have yet to find one student who likes the square root and remembers to say, hey, state that inequality like the inside greater than or equal to 0. I have yet to see one person who remembers this for some reason. I don't know. Maybe it's so different from everything else. Maybe I'm not sure. But if you find a reason why, please let me know. I like to know. Now, another type of function which is presented in section 8.3 is what it's called a piecewise defined function. In other words, a function alone is not enough to define it. An expression alone is not enough to define it. We need 2 or sometimes 3 or sometimes 4 different functions to define a function. So, here's an example. Don't quote me because I'm making the numbers up. Let's say somebody who earns $45,000 by tax code pays 10% taxes. I'm making up numbers. I have no idea. So somebody who makes $45,000 a year pays 10% in taxes. That's one function. For the interval 40,000 to 50,000, a certain function is used to determine that person's taxes. If somebody makes $55,000, it's somewhere between 50 and 60,000. There is another function that calculates its taxes. Comes up with 12%, making numbers up. For somebody who makes $64,000, it's somewhere between 60 and 70. There is another function that gives the result for taxes. This is a piecewise defined function. There's not one particular function that you can plug in everything and get an output. You need 3 different levels, or 4 different levels, or 5 different levels. Another example. If assuming probably everybody now is on unlimited plan, but let's suppose I have a plan on my phone that if I talk for $1,000, I pay $25. If I talk for 2,000 minutes, I meant to say. If I talk for 2,000 minutes, then I pay $50 a month. If I talk for 3,000 minutes, then I pay $50 a month. For each and every of those intervals, for each different number of minutes that I talk per month, there is another function that calculates how much I pay. That's a piecewise defined function. There is not one function alone that solves the problem. You need 3 or 4 or 2 or more. So this is very important. It's important to understand how to graph these functions and be able to identify the domain and range. And you will see we have applications. For example, another good application is postal services. So if you post an envelope that weighs blah blah ounces, they calculate it and they say, okay, such and such, $1.30. If it weighs 2 pounds, it's not the case, then they calculate it in a totally different way, and it's I don't know, $10. Okay, that's a piecewise defined function. It's used everywhere. So I would like to pick up a piecewise defined function and see how we graph it. On page 535, in case you have your books, let's take a look at problem 11. On page 535, we are given the function h of x, and this is 5x minus 5 for x less than 2, and negative x plus 3 for x greater than or equal to 2. As you see, this function has two different pieces. It has two different functions in it. This is a function, and this is a different function. What we need to understand is that both functions make up this one. Not just this or this. Both of them make up h of x. But what I would like to point out here is this. I can use this function only for values of x to the left of 2. I can use this function only for values of x to the right of 2. So that means that I cannot graph them like this. On one interval, I have one graph. On the second interval, a totally different graph. They will not overlap. One graph cannot go this way if the threshold is 2, and this graph cannot go this way because the threshold is at 2. Okay? Good. So here's the technique I suggest, I recommend for graphing these functions. If somebody teaches you another one, or you look in the book and you like the one in the book, use the one you like. Okay, here's what I like to do. First, domain, of course. I cannot do anything before I find the domain. I will look at this interval, and I will change it into an interval notation, basically. At this inequality, and I will change it in an interval notation. Can anyone tell us what is the interval notation representing x less than 2? Excellent. Very good. Thank you. Can anyone tell us now the interval that will replace this inequality? Excellent. Now, please look at this, and look at this, and just think, and tell me the domain of this. Excellent. This will not always be the case. So keep that in mind. Okay, so then we are ready. Negative infinity to infinity. Now, what is the point, the x value that I cannot escape? No matter what I do, that one has to be in the chart, even if I wanted it in there or not.
2.
Why?
That's what x is based off of.
No, it's the threshold between one function and the other. I would not know, exactly, I would not know where something happens. Very good. Exactly. One ends and the other one starts. Correct. Now notice one thing. I have a parenthesis to the left-hand side of 2. And I have a bracket touching to the right-hand side of 2. Bear with me and follow through, and you'll understand what I'm doing. Now, can you please, although I see it here, I would like to write it on my chart. Which function will I be using for x values between negative infinity and 2? Just dictate. Very good. And now which function I will be using? I know it's silly, but I need to put it in there. Between 2 and infinity. Negative x plus 3, of course. What type of functions are these? So I know how many points I need. Because if you say they are square roots, then I may need maybe 3 points. If you say they are linear functions, then I need how many? Exactly 2. Very good. Perfect. Okay. So in this interval, I have 0. I will also plug in 1. 0 has to be in the chart. 2 must be in the chart. I have no way. It has to be there. But the reason why I chose 1 is because I see the x and y intercepts. So please plug in 0 and give me the answer. Perfect. Please plug in 1 and give me the answer. Perfect. Please plug in 2 and give me the answer, and you should say no. I won't plug in 2. Because 2 is here. 2 is not here. Why do you want me to plug in 2 in here? If you don't want to plug in 2, I would have to agree with you. But then you have to plug in 1.9999999999999. So what I recommend, let's plug in 2, and we will leave it as an open point. Otherwise, you have to plug in the closest number to 2, and I don't even know what it is. So please plug in 2 and tell me the answer. Right here inside the parenthesis. Good. Now on this side, of course, I'm going to plug in 3 as well, but please plug in 2. Can you plug in 2? Yes, because there is a bracket. I can plug in 2. So plug in 2 and tell me what you get. 1. And please plug in 3 and tell me what you get. Excellent. That's all we need. So now please give me the first ordered pair from left to right that I have to plug. Excellent. 0, negative 5. Next ordered pair, please. 1, 0. Next ordered pair, please. What type of point is this? Very good. And connect and extend. This is done. You cannot extend it to the right. I'm going to use a different color, but it doesn't mean it's a different function. It's a different piece, but it's the whole thing is one function. Okay, next ordered pair, please. Full point or empty point? 3, 0. Here it is. Careful, they have to, don't draw this. I just want to show you that it's on the same vertical. Do not draw this line. I'm going to erase it. I just want to make sure that it's on the same line. Okay? Because for some reason, from me standing here, it appears that they overlap a little bit, and that's not allowed. Good. Can anyone now identify the range of this piecewise defined function? Yes, but it's negative infinity to 5. From the lower to the higher, to the highest. Very good. This is the way we graph a piecewise defined function. Extending this like this and extending this like this will bring 0 points on the test. Is that clear? Is that clear why the orange function ends at 2, 5 and the blue function starts at 2, 1 and continues to the right? And they cannot overlap. Is that clear? If you graph them overlapping, this is not a function. By the vertical line test, it's not going to be a function. So if you continue this and continue this by mistake, and you cross it with a vertical line, you will not get a function. And this is a function. So please be aware of that. Okay, I think we should look at one more example here. I want you to have 2 examples at least before we look at the last section, 8.4. And I'm going to pick a problem from page 548. Let's say problem 56 on 548. And it's g of x again. And that is 4x minus 3 or 2x for x less than or equal to 1 and for x greater than 1. Same thing, we would like to be able to graph something like this. How do I start? I have to identify the domain. Good. So what will this be in interval notation? Very good. What will this be in interval notation? Very good. Can anyone now state the domain of function g? Not this piece and this piece. The domain of function g. Very good. It happens that it's all real numbers. Which value we cannot omit from the graph, from the chart? Yes. Look at the symbols underneath. Bracket to the left facing left, parenthesis to the right facing right. And they are touching. When they would not touch is when the function doesn't exist there. Good. So, or maybe there is a value in there, something else. Okay, now I need to identify which function I will use for which interval. Which function will I use for the first interval? And which function will I use for the second interval? Right. I know it's redundant, but it's better to have it up there. What type of functions are those so I know how many points I need? Linear. Very good. So let's plug in 0 and tell me what you get. Please plug in 1 and tell me what you get. Yes, 4 minus 3 is 1. Good. So please plug in 1 on the other side and you should say no. But we have to. Because otherwise I will have to ask you to plug in 0.9999999999999. So it is 2, and let's say 2, and what do we get? That's all we need. Please dictate from left to right. 4, 0, negative 3, yes. Next point. Very good. Is it a full point or an empty point? Very good. Will you extend this line to the right? Good. Okay, the other branch. 1, 2. Is it a full point or an empty point? Of course, on the same vertical, I cannot have 2 full points. Very good. And then a 2, 2, 4. Now, careful. I would like someone to give us the range of this function.
Negative infinity to 1 to negative infinity.
So, negative infinity to 1
Union.
with a bracket, union,
1 to
but it doesn't start at 1.
2.
2, indeed. There is a gap in there. Very good. Perfect. Any questions? Remember, I posted all my lectures from the traditional class, not hybrid, so you have everything detailed from last semester also. Okay, with more examples than I can do in a hybrid course because we only meet once a week. Okay, the last section is 8.4. This is the last piece for the test. And it deals with relationships between different variables. It's called variation. And we will look at 3 different relationships: direct, inverse joint. So let's talk about direct relationship. I may read somewhere, or you may tell me, y varies directly as x, or you can tell me y is directly proportional with x. If you tell me or I read any of the two, here's what mathematical expression replaces this. Either this or this, they're the same. Y equals k times x, where k is a constant of proportionality. Y equals k times x, where k is a constant. When we talk about direct relationship, we really say this. If x increases, what does y do? Increases, right? They're direct. It's a direct relationship. If x decreases, y decreases. They go in the same direction. Okay. Let's look at an example of this. On page, for direct.